Greetings to all of my fellow physics students. Today I will be discussing Einstein's theory of special relativity. I hope this helps you as you take your next step in modern physics. Einstein's theory of special relativity starts with two rules or postulates. The first rule is that the speed of light is constant in a vacuum situation. What does this mean? That means that in any vacuum situation, the speed of light, which is approximately 300 million meters per second, will stay 300 million meters per second throughout this vacuum situation. That's why it's a constant. The speed of light will be constant in this vacuum situation. The second rule is that all objects, for the situation to be to be considered in special relativity, all objects need to be moving in uniform motion. That means all objects in consideration need to be either at rest or in constant velocity. With those two rules in mind, Einstein moves on to make the claim that time is relative. Time is relative to the speed at which you're going at. If you are moving faster, time will pass slower for you. If you are not moving faster, time will move at whatever rate it was moving at. To make this a bit more clear, I have an experiment that I want to show you.
So we are here at the legendary tree. In order to show how time slows down for me as I'm going to move faster, this tree is staying in one spot. I will be moving at half the speed of light from this tree to that lamppost over there and back. I will do this for 1 hour at half the speed of light. And then after the end of that hour, we will be here and we will see how much I have aged in comparison to this tree. Time for the running. After I just did my amazing running at half the speed of light, I'm back at the tree. Now, the tree in that time experienced 1 hour of time. The timer was with the tree. The tree, along with its timer, is at rest. And at rest, the time experienced was 1 hour. Now, I was moving at half the speed of light, which means time has to have slowed down for me. In fact, it did. With the time dilation equation, we see that I have only experienced 52 minutes of time, while the tree has experienced an hour. Wait a minute. The tree got older by 1 hour, while I only got older by 52 minutes? That's right. To further explain this, I will go down to the basement to show you. Welcome to the basement, or in other words, the lab. Now, you must have all been wondering, how did I experience only 52 minutes while a tree experienced an hour? Well, here's a simulation that might clear it up for you. Imagine I am a mirror, and this here is another mirror. If I move, that mirror moves. If I move sideways, that mirror will also move sideways. And this tennis ball, is the ray of light, or a photon, as we shall call it. What happens is, for the tree, the light is moving in one position like this. In constant position, every hit you make and every lap it takes is 1 second. So 1 second, 2 seconds, 3 seconds, 4 seconds, right? Now imagine I start to move. You notice that the ball takes a longer path. Let me get the ball from here. Initially, when we are in this one place, the ball makes one path, and it makes X distance. It makes the distance of, say, 5 tiles. Keep there and back. But right here, this is 5 tiles. But as I start making motion, this is like when I'm starting to run. The ball goes across like this. It travels more like 6 or 7 tiles, and then 6 or 7 tiles back. Here, it's making a 5 tile there, 5 tile back. That's 10 tile. Over here, it's making a 7 tile there, 7 tile there, back, 14 tiles.
It's covering 14 tiles in what is still 1 second. Because 1 second is determined by when it goes there and back. A little confusing, I know. Let me clear that up again. When it's going, and when we're at rest, it is moving 5 meters this way and 5 meters back. 10 meters, 1 second. Now this ball is always moving at the same speed. This ball doesn't change speed. This photon. Or the ball, as we shall call it. But now when we start moving, this goes over here and then back over here. It's traveling more than that 10 tiles in what's considered to be 1 second, because the time is just getting elongated. The second becomes longer. It's weird because you don't see this normally. This you only see when you experience speeds at close to light speed. Your cars don't move at light speed, therefore you don't notice this. I happen to move out there at light speed. I traveled 8 minutes into the future. That's why this may seem a little confusing, but I encourage you to branch out, to really see the elongation of time as the increased distance occurs. And I'll come back to you if you have any questions. Have a good day.